Okay, so section 3.3, really you can think of this as foreshadowing calculus. So we don't do any calculus. We're not going to do calculus, but these are concepts. The concepts we introduce today will be the key ones when you do calculus. So here's the question. So start off with this. Say you have some function f of x equals x squared plus 2x plus 7, and maybe I should make this a little bit trickier. Say x cubed plus x squared plus 2x minus 7. Okay. And you're wondering, let's say on some interval 0, 5, and 0, 100. And you're wondering, where is the function biggest? Where is f biggest? Where does it take its most positive value? Where does it take, so biggest I mean most positive. Right? So the graph is highest. Where is it smallest? Where's the smallest? Right, most negative. Right, you're looking for the highest and lowest points on the graph, and how do you? This is something that you're interested in, right? Right. You're trying to maximize something. Right? You're wondering at what time or at what point, things are the biggest, things are the smallest, right? You can imagine that this is a useful thing in, say, economics, right? You're trying to maximize something or profit, right? And you're wondering, where is there some point where that is maximized? Are you trying to minimize something? Okay. So where? Maybe you should be asking me, are there points where f is biggest and smallest? Maybe that's sort of a pre-question, because we're sort of presupposing that there are biggest and smallest points, which may not be true. So are there such? Are there? In fact, are there such points? And that's not obvious either. Okay.
Well, don't there always have to be, unless it's like 0? Doesn't there always have to be a highest and lowest point?
Can somebody give me an example? Is it true, for example, that your function will always have a place where it reaches a maximum?
Oh, no, because it can go on.
So even if, suppose we're on, say, 0, 1, okay, 0, 1 here. And let's maybe something like this. Is it true that if you have a function on 0, 1, there's always going to be a place where it attains a maximum? No? Yes? No? Oh, if it's flat, well, you could say that every point is the maximum value, right? So that doesn't mess things up for us. Can somebody think of an example that might mess things up for us? Something?
X equals y.
X equals y? Okay, x equals y. So is there a place where this guy attains a maximum value or a minimum value?
No, because it continues.
Oh, because I'm saying let's restrict ourselves to 0, 1. Okay. But let me toggle your example slightly. And suppose that we're looking on 0, 1, 0, 1 like this, with the open set. Okay. Now is there a place where a maximum is attained? Between 0 and 1, is there a place where a maximum value is attained? Yeah, can you tell me where? Something going on here. Oh, where is the maximum value?
1.
No, 1's not in there.
Oh.
Is there a place between 0 and 1? So here's my set, here's my domain, 0, 1. And I'm looking at the function f of x is x. Is there a place where this guy attains a maximum? If there is, please tell me. And the answer is no, right? The answer is no, because if somebody, no matter what value you choose, let's say I choose 0.999, say, Well, the trouble is somebody could choose a value between that one, and one could choose one just a little bit farther between that value and one, say the midpoint, right? Maybe now we can use the midpoint one. Right? Choose the midpoint between here and here, and that would be bigger. Right? So this function, in fact, sometimes you might not even have a maximum or minimum. I shouldn't have said this. This is sort of this is you don't have to know this. You don't have to know this. Just pretend it doesn't happen. Okay. So where is f biggest and where is f smallest? Okay, so how do you find it, right? How does one find such points if they even exist at all?
Doesn't it have to be Does it have to be equivalent? Well, I know it has to have, but you want to find the biggest point, it's going to have to have x squared in it because it needs to curve, so it needs to have the top point.
Not necessarily, but you could have, I mean, we're going to have like a whole range of functions, right? This could be anything. You have some function, here it is. How do you find where its biggest and smallest point? And I don't want to waste too much time on this. The answer is that at this point we can't. We can't. Okay. But once you get to calculus, then we'll introduce a notion that will allow you to find the maxes and mins for a class of functions. Okay, so we're going to sort of set up the problem at this point with some definitions. So some relevant notions to this problem, to this question. First is the notion of a maximum. So we're saying f of x naught is the maximum value if f of x naught dominates f of x for all x in the domain of f. Okay. That makes sense, right? This is how you would define a max, right? The maximum value is the value that's bigger than or equal to all of the values. Right? Obvious. You should be smarting or not. I'm not even sure why you're writing things down. Okay. The second one I'm not even going to write down. The minimum you define by blah as the minimum value if what? Caroline?
F of x naught is less than f of x.
Less than or equal to?
Less than or equal to.
Less than or equal to f of x for all x in the domain. So it's the lowest output that comes out of this function. The only thing that maybe I'll do is, I'm not even going to write that down, but I'm going to show you an abbreviation for all. One uses an upside down name for all. So you may see that. That's pretty fun. Okay. 3. F is an increasing function and usually one calls this a strictly increasing function. What should be the definition here? So let's translate this notion, right? You know what it means, it goes up. Right? So what should that mean? How do you express that mathematically? I'm not going to ask you, Caroline, because you raised something. Don't feel bad. What do you think? Well, the function's got to be like this, right? Whenever it's going up, right? It's a going up function, right? So you think, well, what does that say about, whenever you've got 2 points, x and y, then what happens? And let's say if x is smaller than y, then what should happen?
It should go up.
Right?
And so
F of y has to be
it's
greater than f of x. Right? That's it. That's the definition. Right? So if for any pair x less than y, f of x is less than f of y. Right? So just how do you translate this thing into mathematical language? Okay. And number 4, again, I'm not going to describe it, but you know what number 4 is and what the definition is. Interesting. Okay. Okay. The most important idea is this one: the average rate of change of a function over a function f over an interval a b. So average rate of change. Sometimes people just call it rate of change. Some of you may know this already. Does anyone know it? How do we define the rate of change, Carol?
the change in x or the change in y.
The change in what is okay? So here you have your function, right? Say,
Oh,
and here's a, b. Here's your function f, your graph of f. Say.
sorry. The change of, in the textbook, it was the change of f of a minus f of b over a minus b.
Okay, yeah. So it's the change in the f value, right? The change in the function over the change in the input, right? So the average rate of change of the function, right? So it's usually one writes this f of b minus f of a over b minus a, right? Or one often writes it like this: change in f over change in x. If x is your independent variable. But I like to think this. In this case, I generally try to think. I like to think of this as time. Right? So it's change as the change in the function divided by the change in time, the average rate of change. Because if you're talking about a rate, it generally has to do with time. Okay? I mean, it's maybe easiest to think about it as dealing with time. Okay. Right, and notice that this is the same thing. This is the same thing as f of a. So Caroline said f of b, f of a minus f of b over a minus b. Is that wrong? Is that wrong? No. Why not?
Because we put both.
It's the same thing. It's the same thing, right? I can multiply by -1. I can multiply by -1 on top and bottom, right? I multiply by 1 and see that this is the same thing as that thing, right? Okay, so it didn't matter. As long as your order was consistent, right? You don't switch. It's b minus f of b minus f of a or b minus a, or f of a minus f of b over a minus b. Okay, but what is this anyway? This is something that you should recognize. What is this? F of b minus f of a over b minus a. It's slope, right? Right? It's the slope of something. If we look at the graph, what is this? It's the slope of, well, here's f of b, here's f of a. It's the slope of, what is it? The slope of what? It's not the slope of f. This thing, we usually say slope of a line, right? What line?
So the line between those 2 points.
That's right, the slope of the line to those 2 points, right? So it's the slope of the line passing through these 2 points. So it's a slope, graphically, it's the slope of the line through a f of a and b f of b. Okay. This sort of line is often called a secant line. That's not quite right, but it's close enough for now. Okay, so just a simple exercise. What's the rate of change? Define the rate of change of function 5x plus 7 over 1, 2, over the interval 1, 2. Let me make Katie do it. So Katie, what do we need to do?
I wasn't sure. I haven't even trying to figure it out.
Okay, that's it. Well, do you mind if I lead you through it?
Sure.
Okay. So what we need to do is we've got this thing, here's 1, here's 2, right? We'll have 2 points, right? And we'll take the f at the second point, right? The change in f over the change in x, right? So we get f of b, f of 2 minus f of 1 over what? 2 minus 1. Okay. Right. And then from there it's just calculation, right? What's f of 2?
1.
F of 2?
Oh, okay. So 12. No, wait. 17.
17? Right, and f of 1? 12. Yeah. Right. And then we get 2 minus 1. Right. And so the rate of change is 5. Okay. Suppose any questions so far? Everyone get that? Suppose instead of giving 1, 2, I just said A, B. So then we have f of b minus f of a over b minus a. Right? So over just the interval a, b, where a can be some number and b is some other number. What happens then? Can somebody just read off what will happen after we start? Yes, please. Am I saying anything properly?
Yeah,
The question is, tell me what this is. What's f of b? Same function. 5x plus 7. X goes to 5x plus 7. So f of b is
5
plus 7. And just chopped off of a. 5x plus 7. And we divide by b minus a. And you see what happens, right? What do you get?
0.
5b plus 7 minus 5a plus 7. Well, right? 5b minus 5a. The others we get 5, right? We get 5. So in fact, it didn't matter what points, I could have given you any points here. Right? What we see is that the average rate of change of this guy is 5. Right? No matter what interval, and that makes sense because it's a line. Right? The thing is a line. Right? The thing is a line where the average, graphically, the rate of change is the slope of the line through these 2 points, through those 2 points. Well, whatever 2 points you take, A and B, slope is 5. Right? The thing was a line to start off with. Right? That's what a line means, basically. A line is something that has a constant rate of change. Right? A line is exactly the function with a constant rate of change. No matter, right? That's basically what a line is. Right? The rate of change doesn't vary. Any questions? Okay. Let me toggle this again a little bit. So this is 2, 3. And now let's do it over the interval C plus H. The same. No. I'm sorry, let me change the example. So, another example. 1 over x over 1 comma 2. So the rate of change of x is this function, right? And we want to find the rate of change over this interval. Okay, I'm going to make you do it. How do we do it? What's the rate of change? Well, just the
When you plug in,
change it up, so we'll change x, right? Which is what?
it would be 1 over 1 minus 1 over 2
Okay.
over 1 minus 2.
Right. So what you gave us is f of 1 minus f of 2 over 1 minus 2, the change of f over the change in x. Right? So for some reason I always do it the backwards way, but this way, as we said, is the same. Right? And so what do we get? We get 1 minus a half, that's a half. And then on the bottom, we get negative 1. And so we get negative 1 half. Negative 1 half. Right? That makes sense, right? You've got this guy. Right? Here is 1, 1. Here is the point 2, 1 half. Right? This line is a line with slope negative 1 half. Right? It's got a negative slope. Okay. Now let's change the interval to C comma C plus H. Okay. And we can do it together, right? This is just, you have some point C, and you have some little number h, and you're looking at, this h is something like the length of the interval. If h is positive, it's the length of the interval, right? And so let's calculate the rate of change. Katie, you want to do it again?
That would be equation?
Yeah, for the same function.
Okay.
Yes. Example number x now over c is equal to h.
So we have 1 over c minus 1 over c plus h over c minus c plus h. Or just h, yeah.
C minus c plus h. Okay. As an exercise in arithmetic, does somebody want to simplify this for us? Lauren?
So can you multiply on the top both sides by c plus h over c plus h, share the same denominator?
Okay, so you're going to find, so you're going to, wait, what are you doing? You're going to,
Well, if you multiply, so like if you multiply to have same denominator, you'll get
Okay.
c plus h over c times the quantity of c plus h minus c over c times the quantity of c plus h on the top, and then you have the same denominator.
okay, so I think what you're saying is, sorry, for some reason I can't hear. But what I think you're saying is that find common denominator, right? So you multiply this guy by this,
Yeah.
you multiply this guy by
Yeah.
this. Right? And then on the bottom, well, we just get minus h, right? Because we get the c's cancel, we get a minus h left over. Right? And so on the top here, we get c plus h minus c over c plus h, everything over this minus h.
And then you can cancel out the c's.
Cancel the c's. You get h over this thing. Well, we can cancel out the h's, right? So we get, right, we've got this h, right, this is h over c plus h, and then we've got this 1 over h, 1 over negative h, right? So the h's cancel off, and we get negative 1 over c plus h.
If you have to take out the c, the denominator of the, when you cancel out the c's in the top.
No, that was a subtraction. That was a
Oh, I
subtraction.
see.
Yeah, c minus c. I wasn't canceling here. I wasn't canceling
I thought it was.
this one. I was subtracting. Okay, so that's the that's the slope over, that's the slope, so that's the that's the average rate of change of this guy over, so this is the function of x, right, over the interval c plus h, right? Yeah, but
If the formula for average rate of change is
Yeah.
f of b minus f of a
Yeah.
over b minus a,
Yeah.
why are we even doing a minus b on the bottom for the past two?
because we took f of a minus f of b on the top, right? We said it actually doesn't matter which order as long as we keep it consistent,
Okay.
right? Because if f of b minus f of a over b minus a, I can multiply by 1, right? Negative 1. I multiply by 1, right? Okay,
Yeah, no, I get it.
okay. And it's the
I
same
just
thing.
missed that step.
F of b minus f of a minus f of b over a minus b. Doesn't matter which order. Okay, so okay, so right, so the way you want to think about this, or so let's do okay, so you notice that we sort of one has sort of like two ways of expressing an interval. like you've got different ways of expressing lines, and each way sort of emphasizes a different facet, right? If you've got an interval, one either expresses it as a comma b, right? So you could write this as a comma b, or you could write this as a and then a plus h, right? Or as we were just writing, c plus h. Right, the first way sort of emphasizes the endpoints, right? Tells you what the endpoints are. The second way emphasizes the left endpoint and the length of it, right? The left endpoint and the length. It might seem like, why do we even care about expressing the integral in these two different ways? It's not that important, but it will once you get to calculus, it will show up repeated. You go this way or you go that.
Wait, so is this C supposed to be the?
It's actually A.
Okay.
It's actually A. Right. So I'm going to write it as C plus H. Really, the C is A, and the H is B minus A. Right. The H is B minus A, the right hand. So I think in the problems, sometimes they'll express the integral one way, and sometimes they express the integral the other way. And it may seem like, what's the point of it? It will become clear, I'm afraid, only when you go to calculus. Although maybe I can sort of explain it right now. Okay, I'll explain it right now. Why not? So let's look at this guy, x squared plus 2x minus 7. And let's look at the rate of change over C plus H. Okay, so that's going to be the change in F over the change in X, right? So that's F of C plus H minus F of C over C plus H minus C. Right? Which is, right, F of C plus H is C plus H squared plus 2C plus H minus 7. And then we subtract off. Subtract off f of c, right? F of c is c squared plus 2c plus minus 7. Right? And we divide everything by c plus h minus c, which is just h. Okay. Using your knowledge, your pre-calculus knowledge, right? You get c squared plus 2ch plus h squared plus 2c plus 2h minus 7 minus c squared minus 2c plus 7 over h. Right? And then some cancellation occurs. Right? The c squareds cancel off, 7's cancel off, the 2c's cancel off, right? And you're left with 2ch plus h squared plus 2h over h, right? And you notice you can factor out an h out of the top and cancel out the bottom guy, so you get 2c plus h plus 2. This thing is h times 2c plus h plus 2 over h. So you cancel h out the top. So you should be 4. But, okay. So what is this? This is the rate of change of the quadratic. This time, right? X squared plus 2x plus 7 over c plus h. Okay, so like, what you're going to do in calculus is the following. Okay, you think of this as a position. Think of f as position. You think of this f as position. Well, then this average rate of change is the average rate of change of position over change of time, right? Which is physically like velocity, right? Average velocity, right? So this average time. So this 2c plus h plus 2 is the average velocity over c plus h. Okay. Or you can think of it as the slope, or geometrically, it's the slope of this line. Okay. And then what one does in calculus is you let h become infinitely small. Okay. Let h become infinitely small. So you shrink your time interval. Right? You're taking the average velocity over a certain time interval, maybe over 1 hour, and you take the average velocity over 1 minute, average velocity over 1 second, the average velocity over 1/millionth of a second. But you let the time interval shrink in length to 0.
So is that instantaneous rate?
And it becomes instantaneous rate of change, right? And you get so-called instantaneous velocity, or instantaneous rate of change. Okay, so like for us, when the h goes to 0, what do we get? We get 2c plus 2, right? So for this quadratic, the instantaneous velocity becomes 2c plus 2. Now, of course, it's impossible. Instantaneous velocity is sort of an oxymoron, right? It's a contradiction. How can you have velocity instantaneously, right? If you show somebody a picture of a person running and you say, how fast is he running? The answer is you don't know, right? You can't know, right? But you can know the limit of the average rates of change of velocity as the time tends towards infinitely small. Okay. And that's what you call instantaneous velocity, even though there is no such thing. Okay. And this notion of instantaneous velocity is actually the notion, or geometrically, you see what happens. Eventually you get the slope of a line that just touches this point here, right? This is called the slope of the pendulum. Okay, and this is the notion of calculus. Okay, this is the notion of calculus that allows you to solve the problems, the problem that we mentioned before of finding the maximum and the minimum. Okay, and a lot of other things. So this is the big idea of Newton and of Leibniz. That's it for today.